business development manager with TriStar and also an application engineer. And I'd like to welcome you today to view this presentation on our top productivity improvements in Creo Parametric 4. I am recording this webinar so that you can view it later, if you'd like, at the TriStar website. This should be available later today for those of you who want to view it again. So, we have a few things to discuss today. First, we're going to introduce you to some core productivity enhancements around the modeling and assembly environment. First of all, we have some enhanced selection tools. We have optimized pre-highlighting, geometry-based selection, surfaces, and edges. We now have ability to use a box selection tool, and we also have a mini toolbar that appears when we select on objects. We have some user experience enhancements, especially with the full screen mode now, so we can toggle using the function 11 key to a full screen mode and then back again. We have improved user interface customization tools, easily customize the ribbon, as well as mini toolbar customizations. We have 3 new color themes: light, gray, and dark gray. Some core modeling improvements. We have a new intuitive sketching environment with mini toolbars and box selection. We have enhanced sketcher appearance. We have the ability to clip the model at the sketching plane. We have improved visibility of sketched entities and guides, and a customizable line thickness option. We have more control over our text spacing, improved B-spline projection. We have some improvements in the sketch-based features. We can now access a side to depth in the graphics window. We can extrude to selected and then offset or transform. And we have support for a negative extrude and revolve. We have the ability to sweep a 3D object along a 3D curve. And for data plane creation, we have a new mid-plane tool. With sheet metal, we have some enhancement in the design creation with a new twisted wall user interface, added relief types to edge bend, and a new closed corner option. We now have the ability to use the flexible modeling environment for sheet metal design and improved user experience with mini toolbar for sheet metal specific commands. With Freestyle Design, we now have the ability to create multiple disconnected objects. We can edit and manipulate objects irrespective of their order. We can now import or export wavefront files. We have the ability to split quad faces into n-sided faces. We have the replacement now of the circular menu that was familiar with Freestyle with a new mini toolbar. And we have a new Freestyle tree. With assembly modeling, we have a new appearance state to assign multiple appearances to a component used with all states. The regeneration status, we have a new icon that replaces the traffic light, which is only active when a regeneration is required. Expansion of the notification center, out-of-date notification for mass properties and simplified reps, and automatic locate in tree functionality. We have automatic representations. The system now decides how to open the minimum level of detail versus using geometry or graphics reps. There's a new solid weld option for fillet, groove, and plug slot welds. And we now have component operations available from the right mouse button to access material assignments from material node in the model tree. And mechanism motors are now defined as features in the model tree for easy access and editing. With the 2D detailing in drawing mode, we have some enhancements in the datum feature symbol creation, as well as datum target creation, geometric tolerances creation, and dimension creation. We can now embed images in our drawings, and we can replace the model of a drawing view with a related model. Support now for non-linear cross-hatching styles with industry standard file format included in ANSI and ISO standard patterns and property editing, and standard compliant text and symbols fonts. We have improvements now in model-based definition. Just like in drawing mode, we have in model mode easily to create datum feature symbols, easily create datum target symbols, geometric tolerance creation and editing, and dimension creation and editing. And we have enhancements in the combination view or all state, associate appearance with combination state, managed annotation and supplemental geometry visible using combination state, choose combination states for Creo View publishing, and combination state printing. We have enhancements to the additive manufacturing, increased support for 3D printer connectivity, automatic tray assembly and positioning, and tray nesting and space optimization. There are a few new modules available with Creo Parametric 4. One is the new GD&T Advisor extension. This is a new integrated extension developed by Sigmetrics. This supports guided creation of semantically valid GD&T, extensive help content, and interactive GD&T quick reference. Very easy to learn and use, and this helps us to fully constrain the model geometry. ASME and ISO standard compliant, and seamless integration with Creo Parametric. There's no installation or configuration required. This is improved GD&T feature handling in the model tree and legacy annotation support. There's a new Creo Additive Manufacturing extension. This allows us to automatically create lattice structures in our models, either 2.5D or 3D, and conformal lattice creation. This is a single feature providing full parametric control all over aspects of the lattice structure and full boundary representation of the geometry, not facets. These lattice structures can be optimized in Creo Simulate. And finally, we have a new Creo Render Studio, which replaces the advanced rendering extension. This is provided by Keyshot. We have direct access from the Application tab. We can leverage existing scenes and appearances and create screenshots of and output our fully rendered images. So with that, I'd like to demonstrate a few of these enhancements with Creo 4. And the first thing I want to show is some of the enhancements in the selection tools. For example, if I were to select on some piece of geometry, I get a mini menu that now appears that has options that are available for what I have selected. For example, if I were to select on this surface here, my mini menu appears, which gives me options to act on that surface, and it also automatically locates in the model tree. So by selecting on that surface, I actually have the options to activate that model, open it, edit dimensions, edit the definition, and so on. I can create datum planes, datum axes, points, coordinate system, sketches, and so on. I can zoom to selected, I can view normal to that surface, and I can hide. In this case, I'm going to activate the model. And then I'm going to select on this datum plane, and I'm going to create an extrude. In the sketch mode, we now have an option to clip the model at the sketching plane. This allows us to see what's behind the sketching plane. As we create geometry, we now have the ability to automatically snap to references, so we no longer have to select those objects as references. We have some enhancements in the visibility of our constraints. I have a right side mouse button menu that's improved. In this case, we're going to create a line. And we have new icons now for our constraints. As you can see, we have the new green vertical icon. And this interacts just like in previous versions of Creo, whereas if I want to lock onto that constraint, I can click my right mouse button. If I want to disable that constraint, I can click the right mouse button again, and then back to normal with the right mouse button. So I'm going to just go ahead and lock onto some of this geometry here. We now have the ability to customize our menus on the fly. If I use my right side mouse button, as you can see, we have customize. If I want to add commands to my right side mouse menu, I can do that from this dialog. So for example, maybe I want to add the delete segment to my sketch tools menu. And now when I use my right side mouse button, that option becomes available. We'll edit a few of these dimensions. And we'll complete our extrude. I'm just going to drag this up and lock onto this surface right here, if I can get it. And I do have the option now to add my side 2 depth. And we have the ability to have both depths on the same side of the sketching plane now. I'll finish that extrude, and I'll mirror it to the other side. I can now activate this model directly from the model tree. And we can work in full screen mode by simply toggling using the function 11 key. When we're in full screen mode, we still have access to all of our menus just by moving my cursor up to the top. My ribbon interface appears. If I move my cursor to the left, my model tree appears. If I move my cursor to the bottom of the screen, my tools menu appears. I'm going to go ahead and create an extrude on this plane here. And as you see, I have access to everything that I need while I'm in full screen mode. I'll extrude this depth up to a surface, and we'll add our second side depth to a surface. We also have the ability to create an offset from those surfaces. So from our options dialog, we can say offset from the surface on both of those depths, and then we can drag those locations to be an offset. We'll accept that. And I'm going to create another extrusion at the midplane of this tab here. So I'm going to create an extrusion. I'll create my datum plane on the fly. And I'm going to say between this plane and that plane. And now my sketching plane is actually going to be at the midplane of those two surfaces. Again, we no longer have to select references. We can snap directly to the geometry. And I'll create a circle here. And then just delete these extra segments. In this case, I'll use a through all depth option. And we'll mirror that to the other side. A new capability is the box select. So I'm going to choose my selection filter to edge, and we'll just select all of the edges from those features that I just created, and we'll add a round to those edges. Again, we can toggle out of the full screen mode with the F11 key. And there's our newly created model. Let's take a look at some of the enhancements in the drawing mode around dimension creation and geometric tolerance creation. So here's the drawing of this part. We'll turn off our datum planes. And I'm just going to move this view around a little bit just to give me a little bit more room to work. And then we'll zoom into this location. In our annotation tab, if we want to now add a geometric tolerance, we simply click on the geometric tolerance icon, and it'll allow us to snap to existing geometry. In this case, I'll place this on the base, and we'll locate that geometric tolerance right there. We have an enhanced GD&T editor. In this case, we're going to make this a flatness with a tolerance of 0.003. And we have full access to edit this symbol through this dialog. We'll add a few more and edit these as we go. If I just click out onto the screen, I'm now able to add additional symbols. In this case, I'll add a datum feature symbol. And again, this just now allows us to snap onto existing symbols or geometry. And it automatically assigns the next logical letter in the sequence. In this case, letter A for our datum A. I'll add a dimension here, and we'll just double click and place this diameter dimension. As I'm working on that dimension, I have full control. If If I want to add a tolerance, I can do that right here. I can change the decimal places. I can change the tolerance values. And if I wanted to add additional text, I have a dialog to do so. I can add a geometric tolerance to this dimension. Simply click on the icon and wait till the dimension highlights. We can snap to that dimension. In this case, we'll use parallel, 0.003 at maximum material condition with respect to datum A. So as you can see, we can very easily create these dimensions and geometric tolerances. I have a few more dimensions here to create. We'll say the space between these two tabs. We'll say the tolerance is plus or minus symmetric. Out to 3 places. The value of 0.003. We can add some geometric tolerances to this. We'll use a flatness first. 0.02 is my tolerance. And if I wanted to add another one, I can do that very easily. Click on that geometric tolerance. In this case, we'll use perpendicularity, 0.002 at maximum material condition. Regard to datum A. And then we'll just add one more symbol here to the extension line for datum B. So these annotations are very easily created now and very easily edited with a common ribbon interface. Now let's take a look at some of the improvements in our model-based definition capabilities. So let me just exit out of these files. So working in the modeling mode, we have the very same tools for adding our dimensions and geometric tolerances. In this first view, I'm going to add a flatness tolerance to this bottom surface here. So all I have to do is select on my GD&T symbol. I might want to select the bottom plane first, and we'll place that right there. This again is flatness with a tolerance of 0.002. We can add additional targets to that. And we can specify that that datum A now references this surface. Let's add a few more tolerances. In this case, I'm going to just show some annotations for this hole right here. And then we'll just drag that up so that we can see what we're doing. I'm going to add a tolerance to this. In this case, we'll use perpendicularity with a diametric tolerance zone. 0.002 at maximum material condition with regard to datum A. And then we'll say that that is datum B. Show an additional dimension for this hole here. Just drag that down a little bit. In this case, This is 4 places for this hole. We'll have a tolerance, plus or minus, positive 0.03, negative 0.01, and then we'll add a geometric tolerance to this as well. In this case, we'll use true position. The tolerance of 0.015. With regards to datum A, and in this case, datum B, at maximum material condition. If we want to add additional text, we can do that right here. In this case, we'll say that that's for surfaces. We'll add a few more dimensions and tolerances to this model, and then we'll show you the new GD&T advisor. So I'm just going to add a quick tolerance to this dimension here. We'll edit it accordingly. And then finally, one more dimension. Working on the front, we're just going to add a dimension to the curvature of this cylinder here and this cylindrical surface here, and place that dimension. If we want additional text, we can add that here, and we'll just make this be a reference dimension. Now let's take a look at the new geometric dimensioning and tolerance advisor from Sigmetrics. So in this model, I'm going to go to my applications and launch the GD&T advisor. And this tool actually will guide me through the creation of my geometric tolerances. First thing I'm going to do is just select the tolerance feature, and I'll pick this surface right here. I'll accept that surface reference. And as you'll notice, this dialog will actually guide me through what I need to create or add to this tolerance to complete it. In this case, we're going to use flatness. But if I wanted to try to change this, my drop down allows me to see what would be allowable on that reference. In this case, only flatness or profile of a surface would apply. I'm going to go ahead and use flatness, and we're going to enter a tolerance of 0.003. Once I've done that, my dialog indicates that I have fully defined that geometric tolerance, and I can accept it. I can add another one to this hole right here. We'll accept the references, and then we'll build out this tolerance. In this case, we're going to change to 3 place decimals and have a plus or minus tolerance with a positive of 0.002 and a negative of 0. In this case, our only options are perpendicular and angularity. Now, we do have the ability to use some other options here, but these would result in an under-constrained feature, so we may have to add another tolerance to make that work. But this allows me to see what's available, what's under-constrained, and what's not available. In this case, we're going to use perpendicularity at 0.002. And regardless of feature size. And again, this shows us that we have fully completed the tolerance, so we can accept that. If we want to add additional text, we can do that right here. In this case, we want this to be 8 holes. And we'll just move that out like so. We'll add a few more here. I'll add a tolerance to this hole. We'll accept the references. We'll change our decimal places and the type of tolerance to plus or minus with the values of 002 and 0. Our tolerance in this case will be 0.002 at maximum material condition. And we're actually going to add another geometric tolerance to this for parallel at 0.002. And in this case, regardless of feature size. Again, this indicates to me that I've fully defined that geometric tolerance, and I can apply that to the model. We'll just create a few more here. And accept. We'll just drag that out a little bit here. And then one more. And we'll just add some additional text to this, and we'll say we have this in 2 places. Now let's take a look at the GD&T tree on the left. We have all of the tolerances that we have created in the feature tree. And then we have the advisor tree down below. In the advisor tree, we can see advisor messages, we can see warning messages, and we can see error messages. And we can toggle these on or off. Okay. In this case, I have a few errors. The first one says that the tolerance here that you see here must be smaller than the location tolerance. And we can actually edit that right here. And then the error goes away. We also have this option where it says 0 tolerance is not allowed. So we can edit the dimension as well. Or we can edit it here. If I can select it, let's just drag that out so that we can get to it easier. And now all of our errors have gone away. And we just are left with some advisors and some warnings, but no errors. Okay, now I'd like to share with you the new Additive Manufacturing extension. So I have a model that we're going to add a lattice structure to. And we're going to add some lattice to the inside of this little finger model. To do this, we're first going to edit this feature. Excuse me. We're going to edit this feature. To be through all, to create the void in this model. And then under engineering, we have our new lattice feature. And I'm going to select the inside surfaces where I want to create the lattice, and then my bounding surfaces. So first in this dialog, we have a preview of what that lattice structure would look like, or how it would be built. Now, that's not to say that it's going to be created there. That's just a representation for us. We can choose to select the first cell location. For example, if we had a coordinate system that we wanted to place the first cell. In this case, I'm just going to use the default. We have the ability to scale the structure. In this case, we'll scale it by half. And then we can see a preview of what that would look like. Now in this case, we have some dangling beams and maybe some other things that we might want to tailor or remove. So I have full parametric control over this lattice structure. In this case, I'm going to go to my Cell tab, and let's remove the inner horizontal beams and also remove any dangling beams. And then let's take a look at that. So you can see now that we no longer have the dangling beams in this lattice structure. We can also choose to change the shape from square to triangular perhaps, and we can take a look at what that lattice structure would look like. I can change the lattice type from 3D to 2.5D. I can change the orientation. I can change the shape. And we can preview this as a 2.5D lattice structure, being square. I can change from radial or regular to a quasi-radial structure, or a herringbone structure, or back to regular. Again, I can change the shape. In this case, we'll change it to a hexagon. Take a look at that. Let's change it back, and let's add some drain holes to the cell. Okay, I've decided I want to go back to a 3D shape. Change my orientation again. I'll change my cell to square. And we'll just take one more look at that. I also have the ability to modify the density of the structure. So to do that, I'm going to use this surface to help define my density. Under density, we'll add a new density set. We'll use my surface as my reference, and then I'm just going to hide that again real quick. And then the distance from that we'll say is 2. And the cross-section size will change to 0.08. And then let's take a look at that. So as you can see, the density of that structure changes from where that plane resided outward. I also have the ability to show this in a simplified geometry view if I don't want to carry the baggage of the full geometry. Okay. And if I do use the simplified form and go to simulate, I do have access to that entire structure. I'm going to go ahead and edit the definition, and we'll put it back to full geometry, and we'll accept that. Okay, let's prepare this for 3D printing. So I'll go to File, Print, Prepare for 3D. Now in this tray editing tool, we have first the ability to select any printers, the 3D printers that we may have available to us. We can add printers at any type. If we want to create a printer right here, we can do that and give the dimensions for the tray. I can auto position this component in the tray, and I can validate the printing to see if I'm going to have any issues violating wall thicknesses or tolerances. Okay, and this tells me that, well, I have a thin wall violation, but can I accept that? I think that's not going to bother me in this case, so we'll go ahead and close that. I can pattern this very easily. In this case, we'll use a direction pattern. And I'll say I want 12 of those in that direction at 40 units apart. And then we'll say in a second direction, we'll create, let's say 4. And accept that. Okay, now as you can see, we have an issue with our models interfering with each other. We can very easily correct that with the auto position option. And it'll optimize their positions in the tray. We can add multiple models if we so choose. So I can assemble, in this case, we'll put the base. And I'm just going to leave that in the default location because I have the ability to auto position in the tray. And then we can pattern that one as well. In this case, we'll say direction, and we're just going to put 12 of these in here. And then we'll let the auto position work to position those for us. Now, we also have the ability to automatically nest these models in the tray, and this would optimize the use of the tray volume. Now, in this situation, this would take several minutes for it to automatically nest, so I'm not going to do that, but just keep that in mind that this is an option that we have to automatically optimize the position of these models in the tray. We can preview the 3D print. We can show the support material. We can clip the model, or clip the tray, I should say, just to see how that support structure would be built. And we can also edit the tessellation. As you can see, we've got a pretty rough edge here. So if I choose to edit the tessellation, I have the ability to modify the chord height, the angle, the step size. We can allow negative values, the proportional chord height, the proportional step size. In this case, I'm just going to change the chord height to minimum. And we'll accept that. And this, as you can see, that smooths out that edge fairly nicely. Okay, if I'm ready to print this, I can return to the tray, And then I'm just going to do a file, save as, save a copy, and we can change this or save this to a stereolithography type. And I think there's another type in here which is the VRML, which is also a 3D printing type of file. And then send that to our printer. Okay, that concludes my demonstration. I have a few more slides to share with you, and then we will open up for Q&A. So here are some helpful links. One is for our TriStar Resource Center, where we can see recordings of these live webinars, where we also can broadcast. We have a broad range of topics that we cover in depth, and these are all done by our TriStar application engineers. PTC offers a learning exchange. This is free videos, tutorials covering many aspects of PTC software, typically 10-minute videos or less. And then we can also see enhancement details page to find out what's new in Creo 4 for review. At this time, we are offering some time-limited offers available from our TriStar webpage. First is a 30-day trial for Creo 4. Also for Creo PTC Navigate, we have the Application Developers Toolkit. For the new GD&T Advisor extension, we're offering 25% off. And some discounts on training with TriStar now through March 31st. And you can visit these at our webpage following these URLs. At this point, I'd like to open up to questions. So if you'll just enter your questions in the dialogue of the webinar, and I'm going to try to answer these questions here. Let's see what we got. If I can see them. Are you able to attach the datum directly under a diameter dimension? We can attach datums to the dimensions, yes, the symbols to our diameter dimensions by dragging and dropping. Next question, have any of these enhancements requests been addressed in Creo 4? What enhancement requests? If you can elaborate. The next question, this part should have an external reference created in the assembly. Yes, that's correct. By snapping to those assembly dimensions, or those assembly references, I am creating external references. Now, we can remove those references from the reference dialog while we're creating the features, if we so choose. So by snapping to the geometry, we're using those references, but we can remove them, in which case the dimensions for those entities would appear. Add ability to Creo Simulate to copy simulation features from one part or assembly to another. I'm not too sure about that, but if I can find the answer, I will make that available. Okay, trying to look through some more questions. How does the replacement of drawing models in the view work? We can replace, if we choose to replace the models in the view, we can replace by family table or by simplified representation or by similar models. So what that allows us to do is replace the models in the view without losing the view definition, for example. Is GD&T created in a drawing mode added to the model, or they are just part of the drawing? When you're adding to the drawing, yes, they just become part of the drawing. Again, when we create the datum in drawing mode, the datum is only in the drawing mode. When you create a datum through the drawing mode, will the datums be attached to the model? No, not in this case. Unless we do it in the model mode, we can add the datums there. Yes, Creo 4 create solid welds that can be used in Creo Simulate for weld-related castings? Yes. Those now options for creating solid welds in the assembly. Question, will the presentation slides be available? This presentation is being recorded and will be made available on the TriStar website later today. And I think that's my last question. I don't see any more questions showing up. So with that, thank you very much for attending today, and we appreciate your time. Again, you can go to the TriStar website to view a recording of this presentation. Thank you again.